The annual rainfall in a certain region is approximately normally distributed with a mean of 41.5 inches and a standard deviation of 5.5 inches. We're asked 3 questions, and we're asked to round to the nearest tenth of a percent. So let's focus on question A first. Question A says, what percentage of years will have an annual rainfall less than 44 inches? All right, so how would we go about solving this problem? I think the first step is for me to visualize it. And so I like to draw a picture of my normal curve. And this just helps me to visualize everything that's going on. So I'm going to draw my normal curve that corresponds to this particular problem. The mean is 41.5 inches. So right here in the middle of my curve, that corresponds to 41.5 inches right there. I also am told that the standard deviation is 5.5 inches. So if I was to add 5.5 inches, right, to 41.5 inches, that would give me a total of 47 inches. That means when I go 1 standard deviation away from the mean, I'm at 47 inches. That actually happens to be where our z value equals 1. All right, so far I have my z equals 0, which is right here sitting at 41.5 inches, right? That's where my z equals 0. I've got my z equal 1 sitting here at 47 inches, and I'm asked what percentage of years will have an annual rainfall of less than 44 inches? Well, I can see now that 44 inches falls somewhere in here, in between 41.5 and 47. So somewhere in here, we have 44 inches, and it corresponds to a particular z value. Once I have that z value, whatever that z value is, I'll be able to then calculate or talk about the percentage of years that will have a rainfall less than it. In other words, I'll be looking for the area here under the curve to the left of 44 inches. So the whole goal is to get this z value. All right, so that's first. We got to get that z value. How would we do that? Well, I'm thinking I might go ahead and use a little bit of mathematics, specifically proportionality. What do I know? I know that z equal 1, or 1 standard deviation, is equal to 5.5 inches. I'm told in my problem that 5.5 inches is equivalent to my z value being 1, right? Well, that's going to help me because why? Well, because I can set up another proportionality over here. I know that 47 is 5.5 inches away from 41.5. 44, how far is that from 41.5? Well, 44 inches, if I subtract 41.5 inches, if I subtract 41.5, right, what does that give me? That gives me 2.5 inches, right? That means that I now have 2.5 inches to traverse, and I can set up a proportionality. I want 2.5 inches corresponding to 5.5 inches. In the same way, the z value for 2.5 corresponds to the z value of 1. Right? Standard deviation, 5.5 inches, corresponding to a z value of 1. Well, I have 2.5 inches away from z equals 0. That corresponds to what z value? I'm setting up a little proportion, and once we set up a little proportion, remember, from way back when we did problem solving, we can solve proportions by cross-multiplying and dividing. So if I take and cross-multiply, that gives me 5.5 times z equals 2.5 times 1. In other words, z, that corresponds to 2.5 inches, is equivalent to 2.5 divided by 5.5. And if we pull out our calculators and take 2.5 divided by 5.5, what do we get? We get approximately 0.454545, etc. Okay, it's a repeating decimal. All right. Okay, so now I'm in good shape. Why am I in good shape? Because I now have a z value corresponding to 44 inches. That z value is approximately 0.4545, etc., etc., etc. And once I have my z value, now I can use my table of values to get the area under the normal curve. So here we go. Z is 0.4545. All right, 0.45. So I'm going to get to my chart and I'm going to look for Z being 0.45. So I'm here in this row, 0.4. Moving over to the right gives me 0.45, and that gives me 0.17364. That tells me that the z value, that tells me, what does that tell us? That tells us that the area under the curve between the mean and this particular z value is 0.17, and I should use a different color because that yellow is kind of really dark there. Really light there. That tells me that that area right there, that yellow shaded area, is 0.17364. That's what that z-score gives us, that area right there. Awesome. Do you see we're almost done now? We wanted the total area less than 44 inches. Well, I have part of it, right? Now I need the rest of it over here. But what do we know about the area on an entire half of my graph under the curve? Well, the area on the side completely on this half is exactly 0.5 because it's half of the area under that curve, right? So that's 0.5. So if I want to get the total area that's less than 44 inches, I need to take 0.5 and add to it 0.17364. Putting those together gives us 0.67364. 0.67364. That is the percentage, that's the decimal representation for the area less than 44 inches. And specifically, the problem's asking me to write it as a percent. So I bring my decimal 2 places to the left, and that corresponds to 67.4%. 67.4%. And that's the percentage of years that have an annual rainfall less than 44 inches. Now, in the follow-up video, I'll go ahead and do the next guy, which is more than 39. And then I'll do one more video with 38, between 38 and 43. But that gets us through the first problem. If you have any questions, don't hesitate to contact me.